What are the types of work in thermodynamics? Have you ever wondered how energy moves from one place to another in the world of thermodynamics? Today, we are going to break down the different types of work that play a key role in this fascinating field. Understanding these types can really help you grasp the basics of thermodynamics and the first law of thermodynamics. In thermodynamics, work is all about energy transfer. It happens when a force acts over a distance, moving energy from a system to its surroundings or vice versa. There are two main categories of work: mechanical work and non-mechanical work. Let's start with mechanical work, which is the most common type. Mechanical work involves forces causing movement or displacement. One key type is pressure-volume work. This occurs when a system's volume changes against an external pressure. Think about a gas expanding or compressing in a piston cylinder device. The work done can be calculated using the integral of pressure with respect to volume change. This concept is central to many thermodynamic processes, like those that happen at constant pressure or without heat exchange. Next, we have shaft work. This type of work is done by rotating shafts, like those found in turbines or compressors. Here, mechanical energy is transferred through rotational motion. Another type is spring work. This happens when you compress or stretch a spring, storing mechanical energy in the process. Then there is work on elastic solids, which involves stretching or compressing materials like rubber bands. Lastly, we have rotational work, which is associated with rotating bodies where torque causes angular movement. Now, let's move on to non-mechanical work. This type involves energy transfers that do not directly relate to mechanical forces. One example is electrical work, which involves energy transfer through electrical currents or potentials. This can be seen when charging a battery or running an electric motor. Another type is magnetic work, which occurs when the magnetic state of a system changes. There is also electrical polarization work, which is related to changes in electric polarization in materials. Understanding these types of work is essential when applying the first law of thermodynamics. This law states that the change in internal energy of a system equals the heat added to the system minus the work done by the system. In practical applications, like engines or refrigerators, boundary work, a form of pressure-volume work, is often the primary focus. This is where the system's volume changes as it does work on the surroundings. In summary, the main types of work in thermodynamics include pressure-volume work, shaft work, spring work, and various forms of electrical and magnetic work. Each type represents a different way energy can be transferred across a system boundary. By recognizing these types, you can better apply the first law of thermodynamics to analyze energy changes in different systems.